So, hello everyone. Thank you for being here today. Welcome to my talk, Zucchinis or Cucumbers, or how to benchmark embeddings for similar image retrieval, thanks to your weekly grocery shopping. I'd like us to start with a little game. Imagine that you're building an image recommendation model. Your user is looking at this wonderful vegetable, and your model generates item recommendations that should be relevant. These are the top 10 results you get. Are them any good? Raise your hands if you think all of the items or retrieval finds are cucumbers. Raise your hand if you think at least half of them are cucumbers. Well, the latter's right. Half of those are zucchinis. And the only way to tell it apart from me is the shiny plastic on the cucumbers. Let's do another game, and I'm really sorry for that. It's the last talk before lunch. I hope you won't be too moth-watered. But our users now looking at this nice Granny Smith apple, and your model suggests all of these results. Raise your hand if you think all of them are apple now. Do you think at least half of them are apples? Well, again, you're right. We get one nice mangoes top right, and a little pomegranate on the bottom right. But why am I talking to you at a tech conference about comparing apples and oranges? My name is Nech, and I've been coding pretty much since I was a teen. I'm a software engineer since 2016 at Algolia, and I've been focusing on machine learning applications for the last 5 years. I built APIs and tools at Algolia, from Android UI libraries, helping you build good search interfaces on the mobile, to tooling about voice search so that you can get speech-to-text on any mobile platform into your search interface. Both of these are open source, by the way. I've also been building natural language APIs, and recently I focused on this image recommendation engine, so that if you like this bathroom, we can recommend other ones that you might like too. This is my last project, Looking Similar, an image recommendation API based on vector embeddings and nearest neighbor retrieval to return items that might match your user's interests. Top left is a live example from a customer cabinet parts. If you break a part of your cabinet, you don't throw it all away, you just get the replacement handle. But it's hard to put this into words, whereas I can tell when I see it that the slightly flatter one I need is actually the second case. Same for this example from a Romanian decoration items shop. This is a pretty fancy ostrich lamp, and I wouldn't know how to put that into query words either. But I can see how our model picks up other animal lamps items. I didn't even know that category existed. But we find it up because image vector models are able to semantically embed a representation and to recognize that this is about lamps, decorations, and animals. A last example there, this is an American-based mosaics website, and they have many different kinds of mosaics they sell. When you look at this one and ask our model, we'll find the few other visually similar mosaics that have the same kind of semantic content, here, flowery decorations. So now you know what Looking Similar is, and you can definitely check it out. This is a link to the docs. But let me show you a quick peek of how Looking Similar works. In a nutshell, this is a vector retrieval API. But like John Solitario said yesterday, all great vector-based user experiences are hybrid approaches. So we start from the vectors, using an image model to transform arbitrarily sized images into fixed-length vectors. We then turn them into smart hashes, using a learn semantic hashing representation to hash the semantically close items in the same space of the space we project. Once we do this, we can retrieve them using hierarchical navigable small word representation to give you approximate nearest neighbors from the image that you inputted. And finally, like Sven Simon said yesterday in his talk, having some kind of filtering based on object-level metadata allows you to focus vector retrieval results and enable many different use cases. To me, this works really well. We're solving here the cold start problem when you want to have recommendations on data while you still don't have any kind of user interactions to build collaborative filtering matrices on top of. So this works great, and we are starting to onboard diverse kinds of customers in many different verticals. And one day, one customer caught me by surprise with a question. Do you handle groceries well? How would I know? Do I look like I have groceries in my home? This is a good question. Do we know how to recognize food with this model? If you watch the show Silicon Valley, you know that there are state-of-the-art technologies to recognize food or not food. So clearly, we need to step up our game and to prove that we can do at least as good as that. And at this point, I was pretty confident it would be a day of work. I just need a benchmark so that I can compare our model on the existing data. So I started searching for a benchmark, and I was a bit surprised. I was assuming, surely, if I don't have groceries in my kitchen, someone else's has. So there must be industry standards for testing food image recognition. One industry standard dataset for images is ImageNet. Lots of images, lots of classes, and many of them are about food. That looks like it could work out. And when I looked at the ImageNet data itself, there's nice, more or less user-generated pictures of food. I can work with that. But then I realized there is a problem with using this dataset. I had the expectation that any image model can be tested on any image dataset and benchmark. I would expect something very tidy and organized, like cable management at a data center. The reality is that these industry benchmarks are already used in training, in testing, in validation of those models. And so you'll be biased in many surprising ways if you take this as gospel. It looks more like cable management at my home, if you will. Indeed, when looking at the image model that we're using, which is ResNet vectors, it has been trained using ImageNet data. So if I'm trying to assess its performance on its training data, I will have a very high metric that's also meaningless. It's a self-fulfilling prophecy, and it's dangerous to take this as truth. But what about other image models? You probably heard about CLIP, the OpenAI joint text image embedding model, that has been very successful, made a lot of noise when released, and we have many people integrating it in their tool chains, such as our friends at Pinecone. So maybe I can test CLIP on ImageNet data. When I looked into the paper and the research page, I noticed that CLIP is heavily assessed on ImageNet. You'll see on the right here, 35 mentions of ImageNet in the CLIP research page. So it's not used as training data, but you could say it has been definitely tested and iterated on until it had good metrics on ImageNet. You might say that it has been gamed against this dataset. And so it's not something that I can use and trust for building my own evaluation of the image recommendation engine. So if there is no available benchmark, can I create one? What would it take? What is a benchmark? This was the first challenge on my journey. I cannot find any good benchmark for this use case. But our customers still need an answer. So the one afternoon task turned into a sprint-long challenge. Because if it's hard to find a good benchmark, there are definitely datasets lying around. Can I leverage these? I found a dataset in the paper, a multi-layer hierarchy of natural user-generated images by Clason and al. And this looks good to me. There's like 5,000 images of food items taken in grocery shopping aisles across 40 different categories, 80 different single key items. Clearly, this would give me an idea of the performance of our model for this customer use case. But as you can see, it's not very structured. It is a data folder with tree hierarchy with images. Can I turn a tree hierarchy of data points into labeled examples? There were a few metadata with those images, but it's mostly lowly structured text, description, and some information. I was a bit disappointed. I was expecting CSV or JSON data, not this. So I started structuring the data. I started writing code. And there is a good practice in code, which is you ain't gonna need it. Don't add things that you're not sure will be useful. In this case, what do I do with the description and information? I would argue when you're building a benchmark, you should not follow Yagni. You should rather follow what I called Imani. You might also need it. Keep all the data at hand, because the benchmark you build today for a given use case, which is here image-to-image recommendation, grocery evaluation, might very well serve other people on your team when they're building new features. So how do we go structuring this data? I would call it a kind of magic, which is just good old code. I turned the tree hierarchy, traversing these, transforming each item into a structured record, so that the end result would be something more like this, which allows me to take each individual item and assess it against different properties. This is the first insight I got when working on this project, that labels in a dataset are a kind of ground truth. Hence, you can turn them into a metric. Does this mean then that all I have to do is to write tests for these labels on my data? I'm an engineer, I can write tests. This was really the key insight I found when answering this question. Any label dataset is a benchmark we're asking you to be built. Really, this is the only idea. If you remember one thing from this talk, you should remember this. A benchmark is only a dataset with testable labels. In our case, building the benchmark means just turning the labels of the original dataset into things that we can test to compute metrics over a run of our model on this dataset. This makes it possible for your development practice to be data-driven. From the data at hand, define objectives, measure them, and iterate from there. With that in mind, we now have two steps to work: structuring the dataset and evaluating our algorithm. So the structuring, I will simply iterate on each of the splits in the dataset. I'm not training a model. I can keep all of the data. And I will browse this dataset to create records, save these objects in a data store. Here I used an Algolia index because it's the simplest tool I know to store lowly structured data and make quick sense of it. You can store up to 1 million items in there without putting a credit card. That's good for me. And once I had this process of going through the dataset and creating my structured, I could then define those records based on the properties that I had identified for each of the items, storing that this is a Granny Smith apple, so that it is in the Granny Smith subcategory, that it is in the apple category, and that ultimately the top category is a fruit. And again, a good practice here. You see I'm adding all of the metadata that was listed in the files because you might well need it. So let's keep this textual information and don't erase labels just because you don't need them for now. You might also need it. Now we have some data in a data store that we can run the model on. We can start evaluating our model. But what do we want to measure? The real question is, what do we want to know about our algorithm? Here we have a customer question about the quality of results for groceries. So we want to evaluate the quality of those recommendations. But what does this really mean for our user? It boils down to the problem you're trying to solve. Here, the customer's request was to find the right groceries. So they are interested in precision rather than recall. You want for an apple to have only apples and no hot dogs. They're not really interested in the recall. Having all of the apples in your top 5 recommendations is less of a concern for the customer. What they care about is having mostly apples. But they also care about having something to show. You heard the dreaded no result screen being mentioned a few times already at Haystack. So indeed, always having something and having a low no results rate is of interest for this customer. Then we have our metrics. We want to check that we got results, that for each item it's in the same category, same subcategory, ideally even the same product SKU, that the input item that our model will look at. So I turn these into evaluation criteria. What you're looking at is the bench.py script I built, which for each item in the dataset defines a query to our recommendation API. I will get the recommendations for this query, and I will just look at the hits that we return. If we have some, I can check the quality against the metrics that we define. And if we have nothing, I will just note that down to compute a no match rate that will help us see how many of the items might get no recommendations. I then print overall metrics on the dataset. This is just a cheap trick for your development speed so that you can quickly look and iterate without having to put it in a dashboard. And the evaluation step itself is really just comparing the labels. Is the category of the recommended item the same as the origin one? Is the subcategory the same? Is even the item SKU the same one? The first half of this code is just evaluating my metrics. But you might notice a few what the fucks at the bottom of the code. This is because I noticed in the dataset that sometimes I would have items that have the same subcategory, but not the same category. I think the actual case was a mushroom that was in a vegetable, but another kind of mushroom that was in fruits. If you have any assumptions in your metrics, I was assuming that the same category is an easier test than the same subcategory. Write those assumptions down and test them during the benchmark. You gotta be careful that it could be a garbage in, garbage out case, where if you have inconsistencies in the dataset, you will have inconsistencies in your benchmark metrics. And if you notice them after running, the only sound scientific conclusion is that you should throw away the previous measurements, and I hate it. So it's worth a double check before you communicate your results outside the lab. Another tip I would give you when running these benchmarks in a regular way is to make it reliable. You don't want the benchmark to be run the next day and to look totally different from what it was. The same input, same model, same data points should result in the same scores for the same metrics. So depending on the system you will be testing, you want to make sure that you get consistent results. You want to have frozen any large language model you use, so that updates won't change your model's performance. You want to use random seed if there is any kind of randomness in the tools you use. If you have collaborative filtering matrices that are initialized at random, make sure you initialize them at the same random every time you run the benchmark. And this generalizes. If you have any source of randomness in your system, eliminate it or at least freeze it so that you can have consistent metrics and assess your system week over week as it evolves. So now we have data and labels. The next step in our adventure is to evaluate something. And once I have these scripts, running them is actually quite easy. Here you're looking at an experiment we did replacing ResNet vectors by clip. We'll run them locally, generate JSON predictions, and I can load them in the benchmark and have a nice evaluation of the impact of changing the embeddings. I was expecting a huge impact there. Clip is so popular. We can expect big improvements over ResNet, like we saw in the paper. Here I'm sharing with you some results for the ResNet baseline. And indeed, if we get back to the clip paper, on every category of confusing images, they have significant improvements. So if I didn't have the benchmark, I would say let's just use clip. But I have a benchmark, so I can look at actual results. I am glad that there was one line with the same value, because otherwise you would just think I have put a red column and a green column. Trust me, these are conditional formatting, line by line, excruciating to write in Google Sheets. And the result is that it's just red every time in the baseline on the ResNet embeddings and green every time in clip. I'm an engineer. When I look at that, I get excited. I just want to throw away ResNet and use clip. It's good to wait a little and to graph those metrics, because it's not that obvious that clip is better when you actually look at the significance of the difference. Some of these were non-significant, actually. Worse, in our testing, right now our production scales indexing to 1 million items in 24 hours, predictions included, because we can index with 8 parallel threads when using ResNet embeddings. In our testing with clip, we had to scale that down to 2 parallel threads to avoid having instability and request timeouts on the clip embeddings. I am not saying this is the clip problem. It's probably our engineering team and myself which haven't cracked yet how to use it. But as a pragmatic engineer, this to me means it's not ready for production. I don't see a clear-cut argument for putting engineering effort into replacing a vector embedding by another when the difference on this benchmark is not so big. This to me was insightful because it shows we humans have, and even experts, can have wrong assumptions about how a system behaves. Let's see if evaluating this benchmark can teach us more learnings. I'm going to share you a few concrete results because, again, I had expectations on the strengths and weaknesses of image recommendations. For example, packaged goods. I would have known that packaged goods are hard to recognize. This box of soy gurt looks like a box of milk or a box of anything to me. The reality is that there is so much signal in the labeling that it's very easy for the model to pick it up. I was surprised to see that not only we only have Alpro products, we only have Alpro vanilla soy-gurt product for the first 8 results, and then we generalize to the non-vanilla but blueberry flavored. It's way easier to differentiate than, let's say, a TV and an oven. You might be surprised by this example. I surely was when I saw a customer telling us, when looking at a TV, it recommends an oven. When you look at the data, it is maybe not so different from an image recognition model perspective. It's not so different when you look at the product shot focused, but when you look at the items in context, as they suggest you to use it in your house, I can understand why the model is confused if you're putting TVs in your kitchen. So, on the other hand, you know the idiom about comparing apples and oranges. I had a very strong assumption that fruits are different and that the skin of an orange is totally different from the skin of an apple. Enter pink ladies, which is a kind of orangish apple. When I look at the recommendations on the benchmark, well, I get mostly apples, but I also get 2 oranges in the top 20 recommendations. And I'm not even mentioning peaches and pomegranates on the way. So fruits are not that different from a machine learning model trained on ImageNet classes perspective. This was the core point of using a benchmark. Your AI model's strengths and weaknesses are not what we humans think they are. Which brings the question, now that we have a better understanding of our model, how can we share the learnings from this benchmark? You got to remember why we are doing this. The goal here is not to get numbers at whatever. It's to answer a customer question. What is the problem you are trying to solve with these measurements? If you understand the need, you can understand the right framing and the level of details that you should communicate results with. And to understand the need, we need to understand who we're talking to. Do we just share category precision at 1 equals 99.2? This is the truth, but it's a bit meaningless to a non-technical person. And sharing these raw results might do more harm than good on the perception of your product or of your engineering team. We're talking to humans, not machines, so let's phrase this in human terms. The top recommendation is in the same category as the source item for 99.6% of your product, of all pictures. Because ultimately, your interlocutors are not interested in metrics. They want a quantitative assessment of the usefulness of a product. They want to know if they can trust your API with their use case. And so if what they want is a quantitative assessment of the usefulness of a product, you should focus on making the report actionable. What do you expect your readers to do just after they finish reading your report? How can you optimize for action? This depends what you want to say about our algorithm. Here, we could share the precision. We want to share a metric that's tied to the customer value. You could report precision at 1. It's very good looking, also pretty useless in the context of a recommendation UI. If you look at precision at 3, this is the main customer use case. On a search result page, on a landing page, on a product page in your cart, they will display 3, maybe 5 recommendations, and those need to be spot on. But if you want to look at the hard truth, precision at 30, the whole set of results, is the bottom line. Out of all the images we retrieve for these apples, how many are any good? All 3 are valuable. I would say it just depends what you want to communicate and to whom. I was happy at this point. I now have results. I can write emails. I can write an email to the customer replying to the question, and a message to my dev colleagues to iterate on the model, and a report to my product manager so that they understand what are our current strengths and what are our current weak points. In 3 cases, I would argue you want to optimize for action. So the data is the same, but the goals of your interlocutors are different, and hence the message changes. To my dev colleagues, I might well say, the same product at 3 is around 88.6, and I think we should try these few things to see if we can improve the metric. To our product manager, I want to focus on where we are good in our carousel UI components, which is the main use case for this API, we can expect that 80% of the top 3 results will be the same single key identifier as the user input. And finally, for our customers, we want to tell them the bottom line, that they can be confident that on most groceries in their catalog, the top recommendations will be relevant. These are 3 examples of messages, but you might have different interlocutors. So I think we should think about this with interlocutor personas. First of all, you have technical and non-technical people you communicate with, and you want to serve both. For the technical audiences, they want to know how to run the benchmark. They would love to adapt it to new features, and they're curious what can be improved in our model. So share hands-on knowledge. Make it modular so that people can reuse the benchmark with hands-on guidance on how to run it. Also, mention every limitation you encountered in the benchmark, but also about the model. I now know that we have weak points on apples and oranges. On the other hand, when you're talking to non-technical audiences, you would drown them with irrelevant details if you took the same messaging. They're not interested in how to run it. They want to know how to leverage the benchmark. They need actionable talking points, especially your colleagues in customer-facing roles like sales and marketing. They want to know what they can say about the model, not how to run a benchmark. They must know the core strength. So you want to make the report self-serve, define every term, explain precision and recall in layman terms that make sense for your interlocutors. You want to give ammunition to the customer-facing roles. Show them where it really works. Show the use cases where the feature shines. Maybe share some good demos that they can run in their own calls. And mention the use cases that are best avoided for now. I think as product builders, we need to be humble, to say what works, but also to state what doesn't, to avoid wrong expectations about what our features are. This is about technical and non-technical interlocutors. But you might also want to make a difference between the internal and the external audiences of your reports. When you're talking to your internal colleagues, you want to make them understand the strengths and the weaknesses in a crude light, to know what they can improve and what to focus on. So I would argue you should focus on the edge cases. Where do we fail that looks weird to you? Can we improve those edge cases with different setups without lowering the bar? So have an exhaustive report, focus on those edge cases, and share ideas how you think the feature can be improved. It might just be far in the roadmap, but note them down as you have them. Building a benchmark gives you insights. It would be too bad to lose them. On the other hand, when talking about external audiences, you want to be honest, but you maybe don't want to focus on the weak points. You would rather want to show what use cases are solid, where people can trust your system today, as of now, with their use cases. You want to ace those core use cases, having great documentation, hands-on guides, demos if you can, so that really what you identified as a core strength is leveraged for your product and for your business. When it's not a strong use case, but you see ways to make it work, share the workarounds. We had examples with our image recommendation API where if you're looking at clothing and you have a very slight clothing and visible muscles, it would give you other shots that are also muscles. And if you're looking at a top where your arm is flexed, we might recommend you bottoms with a flexed leg. In that case, filtering with categories is something that would allow you to refine and limit a lot the results that you get to something more relevant. But some edge cases are simply not well handled. In this case, don't try to fit a square into a round. You should rather focus on alternative features that are better suited to this case. And like Trey mentioned in the talk just before, you might want to do rather content-based embeddings, looking at the description of the product, the titles, etc. Maybe these are better than average images. So now we know where our model is strong and where it isn't. We're back to our model. Here we go again. We have a baseline and we can iterate on it. Because product development is a never-ending process. In a good way, I would argue. It is a nice feedback loop where you build something, you test it, you communicate results, and you get back to building. So what did we learn about our models with this benchmark? First of all, The good news is that we support grocery shopping pretty well. So the customer that asked us can go ahead and build value on top of our model. Do you remember the zucchini and cucumbers example I showed you earlier? I had to cherry pick the hell out of it to find an example that had pretty average results. Most of the zucchinis will mostly get zucchinis. And same for apples, actually. This pink lady was really a trickster, because most of the apples you see don't look like oranges. And if you put a Granny Smith in, you might have some golden delicious out, but you mostly get apples. I still saw some edge cases on these examples. Remember the 4 metrics that we had defined? If we look at them for those 2 kind of sets of results, the metrics at 3 don't look so good. On the Granny Smith, we get some results, we get the same fruit category, we get mostly the apple subcategory, but none of them are golden delicious. That doesn't look good. Likewise on the bottom, when I have a shot of a zucchini that also includes a bottom row with some bell pepper, the model is confused, and the results are green bell pepper with also yellow ones on the side. And you might already have ideas how to improve that. One option we considered, as you saw with Clip, is to use a different embedding. We could simply change the vector model that is at the beginning of our system pipeline and see if it improves. Likely, it will improve results on food item and groceries. But I would be wary of taking just this one benchmark as a reason to change the whole embedding. We are now very confident how it works on the food items. And maybe we should try another embedding that will have better metrics there. But not all your users are doing grocery shopping. And maybe someone doing Futurama character matching will suddenly get hot dogs out. Probably this is not what you want. The benchmark tells you one view into your system. But like the philosopher Voltaire said, reading a single journal is watching the world through a single hole. I would say the same for benchmarks. Running a single benchmark is a risk of seeing your system with a single perspective. So we can try other things before changing the image model itself. When you saw the example with zucchinis, one of the issues was that the image is not focused. We also have something else in it. So we could try alternative models. We could try image preprocessing to simply refine the images. There's techniques from basic image manipulation, better contrast, saturation, etc., to more opinionated ones like mixing image paper, where you just blend images together and send the overall vectors to your system. We can also try adding object segmentation. If we focus on the zucchini, we'll likely have better results as well and avoid those bell peppers. We can try many things, adding textual signals in the vectors, embedding the metadata, using joint embeddings like Clip allows that. And those are just a few ideas. You can get creative. This is the whole point of having a benchmark that you can run daily for cheap. You can now afford to experiment as much as you'd like. And you can do it too. I would say now this is your turn. What kind of customer's problem is your system solving? Do you already have data that describes good and bad outcomes? If you don't have, no fret. Can you find a dataset that is close to the use case you're trying to solve? When you'll have the data, think what success looks like to you. Can you describe what you would like to measure as success? This is your metric. For example, if you care about having always something to show, you can measure the no-result rate at K and try to have it as low as possible. If you care about never showing Apple products to someone looking at a Samsung tablet, probably what you want is a category spread at K, where the percentage of items in the category A with recommendations from category B and vice versa should be as low as possible. And sky's the limit. You can care about very complex scenarios when you're assessing a use case. Maybe you want to optimize for the top category XXX while keeping the average quality under control. I would say then you need 2 metrics. One which is the top category recall, and you want it as high as possible, while keeping the category precision above a quality ceiling that you think is the bare minimal to have good general results. Honestly, a metric is right as long as it captures the value you build. And you're the expert in what you're building and in how it is valuable. So you can get creative in the metrics you define, because this is the best way for you to assess the quality of your models. So I want to leave you with this conclusion. You can build a benchmark. A hacky benchmark is better than nothing. We now have a way limited, but way better understanding of the quality of our system. And we didn't have data at hand, but the first data set we found was a good match. I would say that any data is better than none. Thank you.
Thank you. Do we have questions?
Yeah, I was wondering if, to maybe take your idea with the groceries benchmark, is the kind of just the whole idea, what you're saying is you can also do that for different types of benchmarks. So if another customer asks you for like, a DIY store and they want to know if you can figure that out, then you're like, okay, I'll go build a benchmark in the same way that I did for the groceries. Is that like what you're saying?
Yes, I think that's the idea. Right now we have one benchmark, but I'm looking forward to more customers' questions that's going to allow us to deepen this. I think in the long run, even without customer demands, we might want to invest in that ourselves just to have internal visibility on our system. The less control you have over a system, and you saw this is quite a pipeline. We have the vector embeddings, we have the learn hashing, we have the hierarchical representation. Things can go wrong at every step. So if you are trying to build an API that serves diverse customer use cases in different verticals, I think every important vertical for you should be one that you can quantitatively assess like this.
Any other questions?
Yes, thanks for the talk. So it was very interesting. You mentioned 0 results, and it looks like this approach can return 0 results, and it's kind of surprising because usually vector search always returns results because you have some nearest neighbor somewhere. So how come?
Okay, this is an excellent question. It gets back to the talk by Isvan on prefix box that says, if you build pure vector results, it's not a great user experience because there will always be something, even if it's a bad one. So here, our approach was to have a default quality threshold that if the vector's similarity is too low, we'll just eliminate that. You can still control the threshold with your API, so if you want to get all the results, feel free. But one thing also is that we're not really focusing on building state-of-the-art models, but really on building useful products that will create good user experiences. And no result page is an interesting case because a no result page doesn't mean you have nothing to show. In a case where you have no results, well, sure, you could show the closest neighbor that might be a bad vector. But I would argue you should rather show a default state that guides your users back into a happy path, maybe by showing popular queries, maybe by using trend models to show what are trending images and products in the catalog. There are many ways you can create a good UX to recover from a no results page. And so what we recommend to our customers is to consider their no result experience, not necessarily as a failure, but sometimes as an opportunity to guide the users towards your top selling items, towards the interesting queries, towards your new recommendations. So depending on the use case you build, sometimes no results is something you want.
Okay, I have another question, just a quick one. So it's a question about the use case. Why vegetables? Why groceries? It's not the first use case that we can think of. I see very well the use case where you have like very specific items, like you showed the lamp or the things like that, where that you cannot describe easily, and that might not even have a name, so they just it looks like that and that's all. But for vegetables, it's something like they have a name. It's very easy to search them by keywords, and especially the baskets are like 30-40 products, and you don't even have time to make photos of the items that you want to search. So yeah.
Yes, that's a good question.
Why that use case?
I agree that it's It's not the first use case you would think of when thinking image recommendations. I am not exactly sure of what that customer's business was, but if I recall correctly, there are like 2 cases where we see image recommendations as a good first step. One of them is the cold boot problem. When you don't have user interactions and you still want to show some recommendations, you need to make them content-based. I agree, using the title and description can be a good fit. However, the second kind of customers we saw that are begging for image models are those who have more or less qualitative textual data. The example, like the typical example for that is B2B or customer-to-customer marketplaces, which will be selling random listings changed every day with more or less structured text, sometimes in different languages. And I think that customer had a catalog with many, many different groceries that were more or less named differently. Moving away from the food examples, especially as we're all getting hungry, I've been also looking at a sports vertically integrated seller who designed their own clothes and sold them clothes online. And the issue they have is they quickly add new things, new ideas on their catalog. A designer drawn a design, they will create 100 or 300 items and see if it sells. And so the pipeline for adding new items sometimes drops a few metadata on the way. You will add an item and maybe it is a woman leggings but it's categorized in men leggings. Or maybe it is a short but it was called differently. So having a way to leverage images as a source of truth is valuable when the textual data has indirection. And in the case of food, maybe it's called a pink lady or a Granny Smith. I can see it, I can tell it when I see it, it's an apple.
Let's thank our speaker. As has been mentioned.